Lift off.
Live. Liftoff. Hey, welcome everybody to Astronomy Daily Live. It's 2 hours UTC on the 3rd of July, 2019. You can call me Cosmic, and here we are again, gathering together this worldwide group of friends that comes together pretty much every single day and talks astronomy and space and science and other tangential things. Who knows what? But today, I think what I want to do is look at some data from the InSight spacecraft that is currently on the surface of Mars. We'll get into that a little bit here. I'd like to babble a little bit right at the beginning, just to let everybody come in and everybody say hi, and grab your consumable of choice. I've got the HOH here, the hydrogen hydroxide, the acid and base simultaneously. It's just absolutely amazing. I've got about 10 to the 24th molecules here, so it's about probably about I don't know, maybe about 2 or 3 moles of this stuff. So if you're a chemist, you know exactly what that is. A mole, MOLE. It's a mole. Anyway, so I got an email from Atta. She is on vacation. She's out of town. She's with her kids, and these are kids, that she works with. These kids are in some kind of a situation where they're in a shelter, and so they're having a pretty hard time. And lucky them that Atta is there, because it's like, man, they don't know how good they've got it. Well, and maybe they do, but boy, that is a nice ally to have. So let me look at the chat really quick. Say hi to everybody there. Tom, nice to see you there. Carolina Sky, nice video. Very good. And on the panel, Bobby. Hey, what's happening?
Hey, Cosmic. Jim, good work on Jupiter, especially when you got excellent seeing conditions and stuff like that. That is radical.
Yeah, those colors just popped, just absolutely popped. So
Yeah.
it's relatively rare, I think, to sort of see those blues and all of that. So that's nice. And the red spot, of course, was there. The red spot is going through some interesting times right now. So it's sort of I mean, the red spot is never in sort of a static state, but past month or so, or couple of months, I guess now, it's been a little bit more active than normal, and that northern band is really dark. That's really amazing. So yeah, absolutely fantastic. The seeing was on your side, and you did some good stacking and all that. So looks really good. So yeah, everything's good here. So come on in, sit back, relax, grab your favorite consumable of choice, whatever that might be.
One of my shortwave shows will always say, so sit back and relax and cool out for a bit.
And cool out. And I would say chill, just chill, because
Yeah.
we are entering a realm of the cool data realm. And in fact, like I mentioned right at the beginning, I think what I want to do, and this was requested, was to actually go over to the Mars InSight data site and take a look around a little bit. And so that's what I propose that we do. We start with right at the top at the Planetary Data System site, and we go from there. The PDS is sort of the launching point for all of the planetary mission data. It's all there. You can find data from Pioneer. You can find it from Voyager, Juno, all of them, all the um, planetary missions. Now, I don't, you know, you're not going to get any HST or Spitzer or that because those are
I
telescopes.
heard from Tom that the Spitzer mission will end in 2020 at
Yeah,
the
we'll
end of
see.
January.
We we'll see. I don't know if that's a end of mission because they're sort of out of fuel, to be able to maneuver around, or if it's like a funding cutoff. If it's a funding cutoff, I'm sort of inclined to think that maybe that won't happen. Because Spitzer continues to deliver uh, fantastic data. So why stop if you've got something really really good? So, but yeah, these things do have physical lifetimes too. The instrumentation gets old and tired. If there's any kind of fuel or power that is needed, to maintain its orbit or be able to move and it can't anymore, well then okay, it's sort of done. But Spitzer has done really really well. So regardless, um, great mission. But
I know
the
Hubbles is going to be there for a good while too, despite of its failures.
hopefully, hopefully, yeah, it's starting. It is definitely starting to show some signs of age too. But they've had to turn it off and turn it on, cycling power on it. I think it's probably a little bit more complicated than that, but at least a couple times in the past year. So is that sort of a sign that things are starting to get a little weird up there? I think it's got a good orbit for at least another 5 or 10 years, I think. Um, and there's always a possibility that somebody is going to be able to come along, um, latch onto it, and sort of boost it back up. Right? They just have to um, push it up a little bit by increasing its velocity, and the orbit will raise, and that will keep it going. But the instrumentation is probably getting a little bit tired. I mean, these instruments are always on, always, right? Never, ever, ever off. So that's a long time. I think I'm trying to think. I think it's coming up on uh, at at least 20 years. I think it's been a little bit more with on the HST. I think it was launched in wow 88, right? So I think it was 88. So actually, like 31 years. Yeah, yeah. So anyway, so let's go over to the planetary data system and sort of ease ourselves into some InSight data. I was actually looking at this prior to the live stream here, and yeah, there's some pretty cool stuff over there, and I really really appreciate sort of the PR data, the pretty images and the pretty plots and everything that are put out by these missions. But I you know, being a science and data nerd, I really like to look at sort of the raw data, look at all
Yeah.
the wiggles, look at all the flaws and everything else,
Yeah. Like
and
to
go from
welcome
there.
Paige Master in the chat and Chuck Nagel.
Page Master and Chuck, nice to see you both. And yeah, it's pretty amazing. So, all right, let's get over to the PDS. I think I've got it already loaded up here on my screen. So let's go over and yeah, I am ready to rock and roll here. So that I'm gonna share my screen, and here we go. All right, so here's the main page, and I will just for completeness sake, I'll put the link over in the chat just so everybody can follow
Yeah.
along either live um, or if you're watching this later, welcome
Yeah.
and come on in. Could you turn that down just a little bit, Bobby,
Yeah,
please?
I can pretty much do that. Let me
I
see.
appreciate I appreciate it. So over here on the left are all the data releases, and as you can see, just 2 days ago, the Odyssey spacecraft just released data release number 68. So Odyssey, um, I believe, is that Mars? Yeah, that is a spacecraft orbiting Mars, um, and they have a few instruments there, and they've got all the raw data and the processed data from their instruments. Um,
Dang.
the the OSIRIS-REx mission just put out a release a couple days ago too. They're on data release 2, and here we are. Here's Mars InSight data release 1B, they're calling it. So whatever that is, we can sort of look at all the other ones too. We can sort of see. I think I looked at the wrong thing here. Previous releases. Here we go. So here's sort of the data. Now this is the scientific data. This is the raw data, the calibration data, the calibrated data, all the ugly stuff, all the pretty stuff, everything. It's all here. So yeah, you can sort of see the release dates. Um, so yeah, it just goes on and on and on. If you're a data nerd that likes to look at planetary data, oh man, you've got terabytes and terabytes and terabytes of data here. So it goes all the way back to wow. So this is showing
Ay,
everything
ay, ay.
back to 2003 with Mars Odyssey data release 5. See, and now they're up to data release 68. so yeah, lots and lots of data. I don't know what the schedules of all these are. If they have some kind of a schedule where it's like, okay, every month we're going to release stuff, or if they sort of wait until um, memory on the spacecraft is full, and then they do a dump. I'm not exactly sure how that works. But let's go over to the Mars InSight here and take a look. So here's the main page, and I'm going to zoom in a little bit because I know this is kind of hard to see. And so here's a listing of all the instruments on Mars InSight. We were asking about this earlier anyway. And all the data. So they have quite a few instruments actually. They have their weather station up there that is measuring temperature and wind and pressure. They have their cameras. They have their deployment arm, which I'm not quite sure what kind of data is coming from that. I'm kind of curious to know what kind of data is the arm collecting and sending back. So I'm kind of interested in that. There's, of course, a magnetometer that's always nice to have on there. This, I think, is the probe that they are trying to bang into the ground and is currently stuck. So that's what that is. There's this one, which, rotation and interior structure experiment. I'm not quite sure if that's part of the mole here, as they call it, or not. Anyway, they have their seismometer, which has been carefully placed on the surface and has been running for quite a while now, I think. And then they have all kinds of other data that may or may not be incredibly interesting or not. So, well, why don't we just dive right in and take a look at some weather on Mars. Let's see what this is all about here. So I'm going to click on that link, and okay, that brings us to a little page here. Let's see if we can. Okay, so here's. Okay, so these two instruments here. I'll try to zoom in even a little bit more here. It's not a great image, but so it sort of looks like these two things over on each side are measuring the temperature and the wind. And then this guy right here is measuring the pressure. And you can also see on the ground, here's the seismometer, and here's the mole, that they're trying to bang into the ground. And they've got their solar panels, which, by the way, are getting really, really, really dusty. I don't know if that's I haven't heard anything about that being a problem or anything yet. Oh, and they've got the arm here too, which is kind of hard to see. But this arm is able, to lift things around and move stuff around and all that kind of stuff. So, but for this particular site, we're just sort of interested in these instruments. It looks like there's a little, like a little cone here. Isn't that cool? Yeah. All right, so let's go back here to this guy and maybe zoom out a little bit. So just lots of nice reading material here all the time. Here's sort of an example of the data. And like I said, this to me is extremely useful, extremely neat, but it's prettied up and made to look sort of nice and easy to understand and everything, and that's cool and all. But I like to look at the raw data, so we'll keep coming down here. So I guess there are two instruments. There's this thing called TWINS, and there's this thing called PS. And TWINS, I guess, is the temperature and wind, and PS is the pressure sensor. So let's go all the way down here, and let's dive into it a little bit. Here is a directory. It says directory containing data files. So let's take a look at that. So there is the pressure data, and there is the temperature and the wind data. I don't know. Let's look at the pressure. So we got raw data, calibrated data. Let's look at the calibrated data. That's sort of the most useful. stuff, usually. Okay, looks like there's a little bit of explanation here, but oh, I'm seeing a folder that says Sol 0 to 122, so that looks pretty promising. So we'll click
I
on
don't think
that.
there are any Linux apps that can do XML. Here you go, some CSVs. You can use that.
Yeah, yeah. Yeah, so let's take a look. Let's look at the file itself. I think I should just be able to well, if I can't, okay, yeah, it's going to save it. So let me put that in a um, kind of a nice place. In fact, yeah, here we go. That, and I think I've got it over here already. So I was trying to be a little bit organized. Whoop, didn't mean to do that. Let's go over here. There we go. Whoop. Okay, so I think this is the one that we just downloaded. So let's take a look at that file. Should just be a text file. Big though, 2.88 megs. Okay, so I always like when they have a little bit of a header up here to sort of let us know what these numbers mean. So, these are all, just columns of data. And as you can see, well, some of these, I'm not quite sure what they are, like AOBT, quite sure what that one is. There's also a SCLK, I'm not quite sure what that is either. But now we're sort of seeing, here's sort of what looks like a day number and a time. Here's another one here. Here's another one here. This might be actually the UTC. Yeah. See, so this column here is the UTC time of that data point. And then we've got the pressure. So that's what this number is, this column. We've got a thing called pressure frequency, which I'm not quite sure what that means. Looks like they're all 20 though, so I'm not quite sure what's going on there. Then there's a thing that they're calling pressure temp, which seems to be changing a little bit. Let's see how many data points we have here. So we've got almost 25,000 data points here. Should I make this a little bit bigger? Would that make it a little bit easier to see if I zoom in?
I think you're good.
How about
But
that?
it's never hurt, just in case the chat may say something about it.
Yeah. So it sort of looks like there's a pressure value here. And I'm not quite sure what the units are. We should be able to find out what the units are there. And then there's another one that's called pressure, what was it called? Pressure temp. And that's this column. So let's just plot these with GNU plot. I'm sort of, it's sort of hard to tell what these first two numbers are, but if those are some kind of timestamp, I'd like to use those for like the x-axis. Let's see if we can find out what these units are here. That's
I'm not sure how complicated it's going to be and stuff. Or XML are usually spreadsheet files or what?
Well, most of the
I know they
XML
are like
it's usually like metadata. So it's just the data that actually describes the data. Here's the XML file.
And how
But
can it
this,
read XML files?
well,
There's
I
a
think I think it is just trying to. But I mean, there's I don't have any means of processing this. We can just look at the regular file, so it's probably sort of treating it like a text file. So yeah, that's not too useful. Um,
wow.
Calibrated data inventory. Just trying to see if we can. Here's a document. Let's see if we can. It's probably going to show about the same thing. Just
Gonna
trying
be
to see
more
what
garbage.
those first two columns are. Documents, PDS, carriage return line feed. Yeah, no, that's not. It's not really
So
telling
we
us
have to
much. So,
welcome Page Master. We haven't mentioned AOBT, right?
I don't know what that is.
Okay, so ABOT is
Oh,
APSS onboard
oh, yeah.
time.
Okay.
LMSC is local mean solar time.
Okay, cool. Thank you, Page Master. You are the man. So, um, GNU plot isn't going to really like that kind of format. But if AOBT is actually some kind of clock, let's let's use that because it's a nice fractional thing. Yeah, that works. Okay, so I'm actually going to put a little pound sign in front of this that will instruct GNU plot to not plot that row because that would be a little bit confusing for it.
Oh, you're commenting on that. That's what it's called.
Yeah, yeah. So
SCLK is the spacecraft clock.
spacecraft clock. Maybe we should use the spacecraft clock. Let's do that. Okay.
Okay, let me see what Pagemaster put. Because he put a link in the chat.
Oh, good. Thank you, Page Master.
Okay, it's a PDF file. So I'm
Wow,
opening it up right now.
I'm going to grab it
And it's
too.
yeah, go ahead.
Yeah.
Yeah. Okay, it's about the twins and the PS.
Good. Yep. Yeah. So this is just the spec for the data
I
itself.
guess it's
So
telling you how to interpret data.
yeah, well, yeah, it's just an explanation for what all this is, right? The first question is, it's like, well, what is this? So cool. Okay, so and here's all the columns right there. Yay. Okay, good. Let
So
us.
thank you, Page Master.
So let's
Not,
plot the spacecraft clock SCLK
oh,
versus
he also
the
tell you to go to page 8. Go to page
oh
8.
page 8, page 8. Okay, page 8. Where's page 8? Actually, well, this is page 8. Am I looking here right? Is that right?
Red alert.
Page 7. Hey there, Ron.
Let me get a light on. Hold on.
What's happening? How are you?
All right. Doing good. I'll be right back.
Good. I'm going to see if I can find what the units are for the pressure since we're here. Pressure sensor products. That's good. Raw data columns, calibrated data columns. Here we go, page 45. So what this is saying is that it is the pressure in... Yeah, good. So this is the pressure in pascals. Yeah, so here are the columns. So let's see, pressure data frequency. I'm still not quite sure what that means. I guess that probably means how often they are sampling, I guess. Oh, okay.
Yeah, where's the good looking one then?
Oh, she's on vacation. She's with her kids. She's with the kids. And so the pressure temperature is actually the temperature of the sensor itself. Well, that might be interesting to look at. Okay, so let's take a look here. So we've got, so let's do column 2. So let's do that. I got to do all this stuff here. Oh, we have to tell the new plot that we're going to be separating each column by a comma. Data file separator, comma. Okay. Otherwise, it's going to try to separate things by white space, and that wouldn't be very useful. Okay, so let's take a look here. PS calibrated, and whoop, we're going to use column 2, right? 1, 2, and let's look at the pressure first. So 1, 2, 3, 4, 5, 6. Column 2 and column 6. We'll just connect it with lines, little thin lines, black lines. So 25,000 data points. Let's take a look. Okay, so don't know exactly what happened there, but it looks like it was doing something and then nothing happened, and then it just kept going up. So that's not incredibly useful. Let's see if we can see what's going on there. So I'm looking at this column right here, 740, 42, 43, 44, 45, 46, 47. It's going really, really fast through this. I want to see when it decides to sort of stop, because maybe, oh, is that it? Okay. Okay, so there must have been a big jump in time. There must have been a big jump in time instead. So now I'm looking at this column over here, the second column. 76, 75, 74, 73, 72, 71. I don't really see any. Oh, yeah. See, it went from, let's get it here. I saw it. Looking in this, here we go. So right about there somewhere, can we see if we can find the exact moment? Here we go. So for some reason, it jumped in time from 596861 to 877107. It's probably, I don't know if that's the number of seconds. Not quite sure exactly.
Usually, in some form of seconds.
Yeah, but that's like about 16,000 seconds there that it missed in time. So, well, instead of doing that, let's just look at it. Let's just look at it without the time. We'll just do that. Just look at the pressure, not really worry about when that's happening, because we're just looking at the data here. We're not trying to do any kind of serious analysis or anything. We're just looking at stuff. There we go. So I'll make that a little bit bigger. That. So this is the pressure in pascals, and this is sort of the time, right? I mean, it's a data point, and yeah, some pretty interesting structure here, right? There was a
And we'd like to welcome Astro Live channel in the chat. We're looking at InSight
we are
data.
looking at some InSight data from Mars. They just released this data about a week ago or so. We are taking a look at it, and this was just the first instrument on the list. This is the pressure sensor, and we're looking at just a tiny bit of that data set, just a tiny bit. Why don't we grab a little bit more? Let's see here. As you can see, I think this is probably the Sol number here. So Sol 4, Sol 5, Sol 10, blah 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 blah. I'm not quite sure. This document probably
Any
would tell us.
Mars quakes yet, or no?
Well, we're going to take a look at that too. We are definitely going to take a look at that. Let's look at something a little more recent. Oh, okay. Now wait a minute. This might be some kind of calibration data. I'm not quite sure because
Yeah, that's calibration. You want
down,
like the actual real deal.
because down here we're actually seeing something called Calib event. Now, I haven't looked at all the documentation here. We're just going through this for fun. So I'm not going to look too hard at any of this, but these files are pretty monstrous. 132 megs there. But I think we should definitely look at one of these. Maybe let's grab a slightly smaller one. Not that how about that one? That's almost 10 megs. I just have to be aware of how long it's going to take to download. That shouldn't take too long.
Especially when you have the internet as a mind of a slug bug. I mean, I can definitely get that data right off the spot.
Well, some of us have it and some of us don't.
I mean, like I said, this is going to make you jealous. I got 100 up, 100 down.
Cool.
What about you, Ron?
I am not jealous in the least. I am glad that you have that. Calib event. Okay, so that's sort of a different thing. Let's look at the. Let us definitely look at the docs here. See if we can pressure calibrated event. I think that's what all of this is. Yeah. So 16 columns here, and I'm quite sure what any of this means, but we're going to look anyway. Pressure 4 hertz, pressure 5 hertz, pressure 10, pressure raw 20. I'm sort of inclined to look at pressure raw 20, so that's column 9. Let's look at column 9. Let's see, there are almost 100,000 data points here. So I'm feeling very, very wealthy in data. So let's see. 1, 2, 3, 4, 5, 6, 7, 8, 9. Yeah. So let's look at that. It doesn't look like all the data is here. So maybe what we should do, let's just sort of scan down here a little bit and see. It's sort of looking like whatever column that is, that's the only data we've got. I'm going to go all the way to the bottom. Yeah, okay. Well, it doesn't look like there's really any other data. So I guess we should probably just grab that column, whatever it is. All right, here we go. Column 1. Here's 2. Here's 3. Here's 4. 5. Okay, then we've got 6, 7, 8, and 9. Oh, it's actually column 9. That's kind of nice. Okay. Whoop, did I? Crazy, man. I picked the right thing. Can't believe it. All right, so let's see. I need to tell it again to look for commas. And let's take a look at this. Let's do the spacecraft time again. I'd like to, plot this versus sort of some kind of an actual thing. What was that called? Calib event. So that's just the second one. Okay, so plot PS Calib event using 2 and 9 points. What with lines? Let's do lines. Lines. Line width 1. Line color 8 is black. I could make it any color we want, but black is sometimes easier. All right, let's take a look at this. Bam. Okay, so again, there are these big gaps in time. Not quite sure what's going on there, so let's forget about that and just look at column 9. Oh, wow. Oh, don't really know what's going on there. Interesting, I suppose.
Are you ready for a leap of faith?
Am I? Well, this is interesting. I'm not quite sure why the pressure is suddenly dropping and then suddenly going up again. I have a hard time believing that that's anything physical. Not quite sure what's going on there. Why don't we plot the y-axis between 745 and 750 pascals? Let's see what that shows us.
You know, it's kind of like a bit crazy. I love having fun in this live stream, okay?
You do?
But, yeah.
Good.
But I don't like it when people make fun and something that's supposed to give you some informational stuff, like a neighborhood watch group and stuff. I don't like that.
Oh, okay. Yeah, I think I did the wrong column here. 750. Here we go. All right, well, there's a little bit at least. Let's that's like 61,000 data points there. So let's squeeze that down a little bit. Let's just go from like 0 to 10,000. See what that looks like. Lots of data. I like it.
Pagemaster wants to know if those dips could represent a dust storm.
I don't know. Yeah, those dips are very sudden dips. So I don't think so. I don't think so. I would think that it would be slightly more gradual than that. But what do I know? Anyway, so yeah, it sort of looks like, there's an upward slope here. Pressure is rising, and then there's some very, very, very subtle dips. Why don't we go from 746 to 748?
And I think this is actually calibrated data, Astro Live.
I think so. I think so. That's at least what it says.
Well, oh, Astro did want to know if that's atmospheric or calibrated.
So there's a little closer in. Let's go even a little bit more. Let's see here. Let's go from 746.5 to 747.5. So, I mean, we're talking about some pretty subtle changes. So not anything too dramatic here. 746.5, 747.5. Here we go. So yeah, we're probably starting to see a little bit of noise in the data too. I can plot this with points, and we can actually see the individual data points. Type. Let's make it just round dots. Yeah. So let's go. Instead of 0 to 10,000, let's go like 9,000 to 10,000. So we'll just look at 1,000 data points here. Oh, it's way up there. It's so 40. Let's do this. New plot. I'm gonna just let it scale however it wants to scale. Okay, so there's just 1,000 data points, and yeah, it's starting to get a little bit noisy there. A lot of this is real, right? I mean, it's flat here, and then it seems to dip a little bit, and then it goes back up and maybe flattens up a little bit more. We can look at exactly the same thing with lines instead. Sort of see that it's fluctuating. Do you see how it's sort of going up and down really, really, really quick? I don't know if that's noise in the instrument or if that's an actual real thing. Let's look at a few more of these. In fact, let's just go from 19,000 to 20,000.
So what does the graph represent?
What does this graph represent?
Yeah.
Well, we are looking at the pressure in pascals that is being measured on the surface of Mars versus sort of like time here. Let's let's put this back 2 to 9. We can do this a different way. We can go we can look at the first 10,000 data points. I think that's the right syntax. There we go. So yeah, we're not really able to see this time here on the bottom, but that's actual spacecraft time versus pressure in pascals. I think let's go over and see Earth atmospheric pressure pascals. Okay, so one atmosphere on the Earth is about 100,000 pascals, right? I think a kilopascal is 1,000 pascals.
Can you prove that Mars is getting higher atmospheric pressure than the Earth?
Well, it's not going to be higher. It's going to be a lot lower. A lot lower. And we're seeing that here. So I think, am I reading that right? Yeah. See, so normal atmospheric pressure is about 100,000 pascals on the Earth. And we are looking at numbers here that are around 750 or so. So if I pull out my handy dandy little calculator here, I'm going to take 747 and divide it by 101. Whoop, 101. 101,325. So that's about 0.7% of the pressure of the Earth. 0.7. So a little less than 1% pressure of the Earth. Pretty amazing, and that's exactly what I expected. Yay! Let's take a look at the next 10,000 data points. Now, I don't want to spend too much time here because, wow, it's already 2:51. That's incredible. All right, I think we're going to move on because we could spend our entire time just looking at this. But there's so much more. Let's look at some pictures. I noticed that the imaging cameras on here, they actually have JPEGs that we can look at. So let's do that. I'm going all the way back to this launching page here. And let's look at the camera archive. So here, we'll go here. It's got the instrument deployment camera, which is IDC, the instrument context camera, which is ICC, and all data in between. All right, so I'm thinking we're going to go into data here.
Okay, so Astro Live Channel is saying I think a 2,900 pressure is low pressure for a storm, and 3,000 pressure keeps the storms away from Earth. He's wondering about Mars and Titan.
Yeah, I think, and those numbers, you're going to have to check your units on that because I think you might be talking about.
And he posted a tweet that InSight did. I'm gonna check it out.
Okay, cool. I will do the same. I will do the same. Let's take a look here. Oh, is this just the InSight Twitter page? Yeah.
Yeah.
Definitely check that
I'm gonna
out.
look at the latest photo. Oh, the latest video.
Cool. And while you're doing that, I'm going to go over here, and I think Saul, organized by Saul. So Saul 0, blah 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 blah.
Okay. So according to the latest photo, behold the video with the support structure out of the way. He's got to be on the most position.
Mm-hmm.
So
yeah, they're trying to figure out why the mold is stuck. All right, Bobby, I want you to choose a number between 0 and 120.
Let's go with 19.
19.
I think that mold probe is out too.
Oh, okay. 19 is not on my list, so choose something else.
Oh, no, 19.
No 19, sorry.
32. Let's go with 32.
32, is on the list. Yay. Okay.
I think they were finally able to get that probe out.
Oh, good. Wow, that was fast. Okay, so EDR is, I believe, the calibrated data. So let's go with EDR. And here's the ICC and the IDC. I forget what those
Oh no, not
stood
yet.
for
I
now.
stand corrected, not yet.
Not yet. Okay. Yeah, well, that's why I said, boy, that's awfully
But you
fast.
will see the bow there. You will see
Yeah.
the bow.
So let's look at the context camera, ICC. And okay, well, it looks like there is one image here. Let's take a look. I don't know why it's asking me to translate. Okay, so there's the context camera image from Sol 32. Cool.
And this is the twins, right?
No, these are the cameras on the spacecraft.
Oh, okay.
So this is the IDC, which is the oh man, what's that thing called? I'll find it here. Maybe. um, the instrument deployment camera. Okay, so let's go forward. Instrument deployment camera. And there's a couple images here. Let's take a look. I have no idea what these are going to look like. Oh, wow. Okay. So here's the seismometer over here. And it looks like it's got its little cover on and a little thing to grab onto. This is the end of the arm, and this is some kind of gizmo to be able to grab and move things around. This little hand, can actually grab onto this little knob and lift it up if it wants to. All that.
Yeah. Yeah,
Looks like
about that probe that is stuck, they were able to get the support structure out of the way.
Right.
But I think the probe is still going to be stuck.
Yeah. Yeah. No, I think that is going to take a little bit of effort because they, it looks like a pretty complicated problem they have there.
You can definitely see the mode there for sure on that
Cool.
on the recent video.
Neat. So there's another view. Nice and shiny. I don't know what all these weird symbols are here, and why are they located where they are? I don't know. That's a little weird, isn't it? I don't know. Let's see. Let's pick another Sol. What do you think?
Let's go with 70.
All right. Look at Sol 70. Looks like the same thing. EDR. Yep, we have the context camera and the deployment camera. Let's look at the context camera here. Oh, there's a bunch of images here. I don't know why this thing wants to translate.
I don't know. I have no idea either.
I don't know. It's trying to help. This is a really weird looking rock too. Do you see that? It's very symmetric. It almost looks like a large what are those things called? The like the end of a spear. I forget what you call that thing. Anyway, there it is. There's another view. It's a sideways view So you sort of have to tilt your head around. Sorry.
Or
But you
download
can
the
sort of,
photo and rotate it yourself.
yeah, yeah. This sort of looks like before they put the cover on, right? So they were just sort of lowering down the actual seismometer itself, and then this is really insane, right? I mean, it's a ribbon cable. It's just laying out there on the dirt. In fact, it's hard to tell, but it sort of looks like it's gotten buried here a little bit. Now, how would that happen? That's a little weird, but it just, it's just a ribbon cable. Pretty amazing.
Yeah.
And the seismometer itself, you can see the arm here and the gizmo. It's got grappled there. All right, let's. I'm sure these numbers all mean something. I'm seeing a Sol number here, Sol 70. This is probably like the spacecraft time or something. It's hard to tell. But here, let's take a look at a few more of these. How about this? I don't know. That's probably just some kind of overexposure, like a glint or something. That's all I can think. I'm thinking out loud. I'm not trying to give any kind of explanations here. This live stream is not about answering questions. It's about making more questions. That's what this live stream is all about. I have no answers. If you come here, for some kind of answer, you're not going to get it.
And what's also weird is there's no such thing as dumb questions.
No, I totally agree. Now, there are questions that are not really appropriate, and questions that are mean-spirited and all of that. But no, if we can't ask any kind of question that we have, then there's something wrong. So yeah, I totally agree with that. There's really no such thing as a dumb question. There is a bad question, but there's no such thing as a dumb question. So there's a little bit more. Okay, well, there's a lot of these. This goes on and on and on here a little bit.
There's got to be something wrong with Nightbot.
Oh, yeah? So one thing that'd be pretty interesting and something that I could actually do really, really easily.
Astro Live channel says science is all about questions, but a way to find answers.
Yeah, well, questions are part of the process. There's sort of the motivation part, but yeah, a lot more to it than just that, of course. But I could probably download all of these and make a movie out of them too.
Yeah.
So maybe we'll do that at some point.
And hence one of my church hymns, "Put your shoulder to the wheel."
Yes. Let's look at the other camera, the deployment camera. I guess the deployment camera is probably on the arm. Yeah. See, it's right on the end of the arm. So they can take a really, really, really close look at where they are, what they're doing, all that. Here, obviously, they were sort of in the process of very carefully placing the seismometer down on the ground. And again, there's all these weird symbols and things. This looks like some kind of a decal. I don't know what it says. Oh, it says InSight. Yeah, see, it's upside down. Okay, cool. Oh, is that the only one? Oh, no, there's a lot more. So there's another view. Snapping a lot of pictures. You know, they have to be able to see what the heck is going on up there. Ooh, it's let go. Look at that. Let's see if we can see it when it just lets go. Let's go up a little bit. Back in time, maybe. Oh, still where it is. Let's look at this one. Oh, look, it's let go. Look at that. Oh, that's pretty neat. Neat looking. A special moment in time there. Yep, there it is, raised above. So it did that pretty quick. Raised itself up pretty darn quick. Yeah, see between that image and that image. Maybe like 49 seconds, maybe. I'm looking at 40210 and 40259 and saying maybe that's like 49 seconds. They raced it up that far. Just trying to, you know, get a sense of timing here too. You know, how long things take. Things move, you know, very, very intentionally, really, really, really slow because they've got to be super careful, right? They have to be like super duper careful that they don't mess up. Don't want to mess up.
Otherwise, you're just Texas toast.
Otherwise, you are screwed, blued, and tattooed. Absolutely. Look at the shadow. Look at the shadow here, that long shadow. So that means, you know, the solar angle is really, really, really low. The sun is way down here, really, really, really low. I don't know how high this is, but the fact that that shadow is almost 3 times as long, that's like 1 to 3. So knowing that, we could actually calculate pretty accurately, you know, the height of the sun above the horizon if we wanted to, just by looking at the shadow. Look at all this stuff on the arm and all that. Isn't that cool? I like it.
Yeah.
Little, a bundle of wires there. Here's a little rock. Oh. All right, let's
And they control all that by remote control.
well, yeah, not exactly. Not exactly. What they do is they send up a set of commands that you know, will run for the next day or 2 or a week. I'm not exactly sure how long that goes. So and then it just runs through its commands. If they have to stop or anything, then yeah, you know, then yes, you know, it is sort of like um, um, remote control. But the problem is that it's not real time. Light travel time to Mars, you know, there and back can be, you know, 30 minutes or so. So, so yeah, there's no real way to easily, you know, remote control it. But you know, they usually have a program, and you know, they just run through that. It's a set of instructions. So let's look at day or Sol 120 here, just for fun. Sort of the latest and greatest. We'll look at the reduced data. It looks like they just have context camera images here, and looks like just a couple. So let's take a look. So okay. Well, see now you've got the mole over here planted in the ground, or placed on the ground, I guess you can say. So it looks like, you know, they were happy with that, and so they've moved on and place the mole in there too. And it's got a ribbon cable too. Crazy. Let's see what this other one looks like. Pretty much the same. Oh. One more here. Just see if there's a little bit more. Okay, so here's the deployment camera. Whoa. Okay, you got to twist your head the opposite way now. So that's a nice view of the solar panels, or well, at least one of the solar panels. Sweet. And look at all those cables and wires and structure. Really dusty though. Look at how much dust. Wow. That is a lot of dust. Okay. Pretty awesome. Let's go down here a little bit. Oh, all right, so here's the last one. Just take a look at that. Okay, so just, again, you got to twist your head the other way. Nice landscape view of Mars there with a little bit of the solar panel and the arm. You know, this camera's on the arm, I guess, so why we're getting that point of view. Pretty cool. Nice. So yeah, it's kind of nice that they provide those. I sort of assume that these VIC files, that's probably the actual numerical data. JPEGs are not fixed up quite a bit, not really scientifically valid. My guess is that these VIC files are probably the actual data, and their size. Yeah, that sort of shows that a little bit. So, well, cool. Well, hey, wow, there's a lot more to go through here, and I think I want to continue this tomorrow because there's a lot left. We haven't really touched this much at all. We've looked at a little bit of weather, and we've looked at a couple of pictures, but we've got the deployment arm, we have the magnetometer, we have the mole, the probe, we have the seismometer. So there's a lot left here. Why don't we call it for today, and we'll just sort of keep going tomorrow with this. If that's all right. Does that sound okay?
Yep, sounds
Let's
good.
do it. Cool. All right, I'm going to check the chat really quick. Make sure that the shenanigans are going on, because if there aren't any shenanigans, you're going to have to answer to me. I want lots of shenanigans over in the chat. It looks like there's some good ones over there, so good. Yes, it is. It's amazing technology, and I always like to see cables and tie downs and screws and nuts and bolts and stuff. I think it's just amazing because this stuff is on Mars, right? It's incredible. So, all right. Well, as I said, I think for now, let us depart these waters. I'll be back here again tomorrow, 2 hours UTC. Hope everybody enjoyed the solar eclipse. It was great. It was great.
Oh,
It was
yeah,
fast.
that was fun.
It was fast. It was really fast. That just means that the size of the moon and the size of the sun were almost exactly the same. So, but yeah, that is always a very exciting event. I don't know if you noticed this or not, but during the live event, okay, right when the moon, locked off the sun, there was a gradual uh, raising of voices. It got louder and louder and louder and louder and louder until the actual eclipse, and then it went dead silent. Everybody just went dead silent, and there was silence that entire time. I'm getting goosebumps. And then as soon as the moon moved off the sun, everybody cheered again. But during that moment, there was just dead silence. Did you notice that? Isn't that amazing? Yeah. And that is what happens during a solar eclipse, even a partial one. You start to feel that a little bit. It's like, wow, what is that? And it just knocks everybody out. There's just nothing. You're just frozen. It's like, wow. So, okay, everybody,
Yeah.
I'm gonna get out of here for now. I'll be back again tomorrow, 2 hours UTC. More astronomy. I think we're gonna stick with the InSight here a little bit, and see what else we can see.
Right.
There's a lot left. So, okay, everybody, peace, cheers, and all that.
All right. See you next time.
We'll see
And
you
tell
next
a friend.
time. Tell a friend. Make sure to subscribe. Thumbs up if you wish. Make some comments. And yeah, I'll see you next time. Okay, everybody. Bye.